Welcome, everybody. I'm going to call the meeting to order. We look forward so much today to our program, Global Warming and a Planet in Distress, with our speaker, Dr. Michael Bentley, who is well known throughout the Valley and well versed in this subject. I want to thank Janet Johnson for an article that she had put in our Acorn promoting our program this morning. And thank Teresa for her high-tech ability. Is it not clear? I'm sorry. I want to thank Janet Johnson for an article she put in the Acorn, and thank Teresa for her coordinating Michael's visit with us. I'm Nancy Barber, and I will introduce Michael. Michael grew up in Roanoke, and he had a Catholic education through college. He earned degrees from King's College and the University of Pennsylvania, and a doctorate from University of Virginia in science and environmental education. He has taught at all levels and in museum education, followed by university teacher education in Chicago and the University of Tennessee in Knoxville, along with Virginia Tech. In the sciences, Michael has followed environmental change since 1970. He has directed the Science Institute for Teachers at Hollins University in Roanoke for 7 years and served on the National Panel on Science for Education. Among his 24 books, one is called Connecting Children to Nature. And I'm sure that reflects his own love of beauty and wonder of this earth. Without exposure to nature, our young people will surely end up with NDD. That's Nature Deficit Disorder, says Michael. So welcome him this morning, and I ask you to help me welcome him. Thank you.
Now can you hear me? Great, okay. Let's see if I can manage this with one hand on the microphone. This is one of my favorite props to speak with people about. It is a globe, but not like the kind of globes you probably saw in school, where they had the nations marked off with nation states and capitals and all of that. This one happens to look exactly like the Earth does look. It is a composite of photographs taken by NASA satellites over a single day of Earth. And it's extremely realistic because these are photographs stitched together of the same day. Unlike those globes you had in school, this one has clouds because there are always clouds on the Earth. They picked a day that had fewer clouds than usual so that the continents would be visible. And this should be in school rather than those with the nations on them, because the nations of course, are artificial. Now, I'm going to need you to hold that close to me for a minute, okay, because I'm going to do one more thing with it. Now, today, I'm going to talk about what's happening with our atmosphere and our oceans. And the atmosphere, of course, is not visible on here because it's invisible, except for the clouds. But the atmosphere rises approximately 10 miles over the Earth. Now, to scale, I want to show you what that would look like if you could see it, how deep it would be. So I take my business card and I hold it there, and the thickness of that card is how thick the atmosphere is to scale with that Earth. It's not very much, is it? It's very thin, and we share it with every other person on this Earth. The oceans, at their greatest depth, are also 10 miles deep, at their greatest depth, which is also equal to the thickness of this card, even though you see a lot of ocean on the surface. But if you took all that water and all the fresh water, the Great Lakes, balled it all up, the rivers, this is what you would have in relation to the size of this Earth. So the oceans aren't as abundant as you might think from just looking at a globe, because they're only that 10 miles deep at their greatest. So that's what we're dealing with the changes on Earth. And I've heard so many people say, the deniers of climate change say, oh, we humble human beings as tiny as we are couldn't possibly change the climate of this Earth. Well, that's not so, because there's 8 billion of us. And every day we are pumping carbon dioxide into the air. The average person puts 5.6 metric tons of carbon dioxide in the air every year from just living, driving, heating the house, cooking, the everyday things we do. So you multiply 5.6 billion tons, and this is a global average, by 7.9 billion people, and you're going to get a change in the Earth. And that's what we're going to look at today. Thank you very much, and you can pass that around. So we're going to march through a lot of data here, and I hope I don't overwhelm you, but if you have any question at any time, just speak up, and I will do my best to respond. So this is what we're going to talk about today. We're going to talk about our predicament. And our predicament is climate disruption. And I'm going to more briefly talk about the problems. Now, the predicament is climate disruption. The problem is what is called overshoot. We've overpopulated with our numbers and our consumption. Those two things, consumption and numbers, are what's changing the climate. And one of the other aspects of it is we're losing our species numbers quickly. And I know this very personally because my son, 28-year-old Alex Bentley, has been working for 3 years in the jungle on the equator of Ecuador, and he has discovered 3 new species to science. He's a biodiversity researcher, and he tells me that as soon as he discovers them, they're going extinct. Okay? Those images are on the bottom are photos I took. They're 2,000-year-old petroglyphs of Native Americans. So last year, summer, we've probably forgotten the name of Hurricane Ida, but if you live in New York City, you will remember it because they got 7 inches of rain into the subway system, and 13 people died in their basement apartments. And that same storm ravaged New Orleans, and they lost power for a week. It was a Category 4 hurricane. We're expecting an above-average number of hurricanes again this year. Last year, we had wildfires all over the West. This year, they're burning in a different place in New Mexico and Arizona. But they've already covered 300 square miles, and that was in the spring. The summer hadn't even started yet. That was this year. Last year, there was a temperature of 120 degrees in Canada, in northwest Canada. Unheard of temperatures. We had flash floods that killed people in Tennessee. I retired from the University of Tennessee in Knoxville. Knoxville, just outside of Knoxville, that little town was totally wiped out by floods. And of course, what we don't often hear about are the stories of what's happening in Europe. And last year in Europe, believe it or not, Italy got 29 inches of rain in 12 hours. Now, I just got 5 inches of rain in the last 24 hours in my gauge in Salem. But try putting 29 inches into the air in 12 hours. One city got 34.8 inches in 24 hours. Can you even imagine that? Of course, there were many people that died in floods in Italy last year. So, last year, scientists warned that civilization is facing a possible collapse if this kind of thing continued. And we've just seen, if you've been reading the papers, a heat wave in India and Pakistan in May this month, where temperatures came up in some places to 140 degrees Fahrenheit. 140 degrees. Currently, the report is about 70-some people died from heat prostration during that period. So, the Paris goal of the United Nations Intergovernmental Panel of Climate Scientists, which is 1,200 scientists globally, said that we cannot surpass 1.5 degrees rise Celsius. That's 2.7 degrees Fahrenheit in raising temperatures. If we go over that, we're going to really be facing a disaster. How much have we already gone over it? Well, we've gone over it 1.2 degrees. So what I've been telling you about the weather disasters that we've been having has happened with only 1.2 degrees Celsius, which is 2.2 degrees Fahrenheit over the normal. So, we've got trouble in the natural world. And by the way, that little question mark is supposed to be a marker, but this is a PowerPoint I had to convert from Keynote in an Apple computer, because this is not an Apple computer. If it were an Apple computer, you would see this exactly correctly, but it's a little bit different because I had to translate it. Anyway, these factors that are here are all interacting factors. So you've got global warming, too many people, deforestation, which is continuing in the Amazon rampantly under Bolsonaro, their president, who does not have any concern at all for the environment. Species extinctions. We have trouble with soils now because we've lost amounts of soil fertility, and soil moisture have all been on the losing end. The oceans are being affected by pollution, acidification. The acid is turning more acidic, and the depletion of oxygen in the upper stretches of the oceans and the lower stretches as well. And then the shrinking cryosphere, in other words, all the parts of the earth that are covered by ice, Antarctica, Arctic, and the glaciers of mountains. which causes a loss of albedo. Albedo is the reflectivity of the Earth, how much light from the sun gets bounced back out into space. That has decreased already by 0.5 degrees of reflectivity, which is an enormous amount, though it doesn't sound like much. And that causes more heating and is also causing feedback loops. It accelerates the water cycle, makes it go faster, which gives you more frequent storms. Have you been noticing that lately? And this is one you probably have no idea. Anybody know what that is, the AMOC? Anybody? That's letters stand for, it's a mouthful. The Atlantic Meridional Overturning Circulation, which we mostly know of as the Gulf Stream current. But the Gulf Stream current is only the top part of it. So what's causing these problems? The problems are being caused by the emissions of greenhouse gases. The most one that most people know about is carbon dioxide. But there are other ones, methane, nitrous oxide, fluorinated gases, and water vapor. Water vapor is a greenhouse gas. And the warmer it gets, the more water vapor the atmosphere can hold. With every 1 degree of temperature rise, the atmosphere can contain 7% more water vapor. So already we have 7%, because we've already gone up 1.2 degrees. We already have over 7% more water vapor in the atmosphere now than we used to, you see. That is also causing warming. So when I was born in 1946, I'm 75, there was 310 parts per million of CO2 in the atmosphere. Now it is 420 parts per million. So it's gone from 310 to 420 parts per million in my lifetime. And yet for 11,000 years before I was born, it was 280 parts per million. Okay? So between the Industrial Revolution, 1880, and the time I was born in 1946, it went from 280 to 310, and now it's at 420. And every year, it's been going up about 1.5 degrees, 1.5 parts per million every year. It's rising. So when I put this slide in here, I like this slide, but it had 415. That was about 3 years ago. Now it's 420. And this is where it's headed by 2100 if we don't do something. And have we done anything? No. Congress, just like they haven't done anything on gun control, and we get 18 kids, 19 yesterday, murdered in Texas, they haven't done anything on climate change. Nothing. Nothing. So this is where we're headed, and 900 parts per million will destroy civilization and cause massive catastrophes all over the earth. Your grandchildren, I am going to be a grandfather myself for the first time in August, and I'm already worried about that child. Where do these greenhouse gases come from? Well, most of them are coming from the use of energy. And most of that comes from the transportation sector now. So you get out on 81 and you can see carbon dioxide flying out of those cars like crazy. And not the electric ones, though, but the ones powered by internal combustion engines, which is most of them. Trucks, airplanes. Airplanes are terrible emitters of carbon dioxide and greenhouse gases. The most efficient form of transportation is Walking, yeah, can't get very far very far walking anymore at my age anyway. But the trains for mechanized transportation, the train is absolutely the most efficient way to go travel. Yeah, absolutely the train. And we haven't done much with trains here in this country. You can go train rides in most every other industrialized country in the world much faster than we can here, and at much more efficiency. But our trains have not been upgraded. And why is that? Because of the automobile lobby, you know. In this country, bribery to politicians is legal. We can bribe them. And, of course, that's what's happened. They've all been bribed. They've all been bought off, and they're doing nothing because people are lining their pockets as a result of our present system. Yes, ma'am.
How much is
The green is agriculture.
No, not green, greed.
Oh,
As in, I want more money.
oh, a lot. We have to just admit we have a corrupt system in this country. It's run by bribery. There's unlimited campaign funding to politicians, and the only way they get in is by advertising, and they need money, and they get paid off, and they make promises, and they don't do anything. And they get in, and they don't do anything. The gun lobby for guns and the fossil fuel lobby, and, before that we had the tobacco lobby that said that smoking was delicious and good for you, When I was a child, my doctor smoked while he examined me, So this is the long history. This goes back 800,000 years, and these are the measures of atmospheric CO2 levels over the time from 800,000 years. Now, how do we know this? How do we possibly know what the CO2 level was 800,000 years ago or 10,000 years ago? Anybody know?
Carbon dating.
I'm hearing different things, but it is from ice cores in Greenland, primarily. So they take, the ice in Greenland was older than that, 1 million years old, and they've made these core samples. And there are bubbles of air in those ice that haven't changed in 800,000 years. So they simply pop those bubbles and measure what's in them. That's how they know. So you can see there have been variations. There's some, it's gone up and it's gone down. But it's never passed this line until 1950. And this line was 280 parts per million. Never went above that for all of this time, and then in 1950 it started going up and it went straight up. So where did this all come from? Well, more and more people with more and more money, with more and more cars, more and more stoves, big refrigerators and all those things. My mom had a small refrigerator in our house when I was growing up with 4 children. And we had, a washing machine that you cranked. Do you remember those things? So, all of these new appliances and new cars and bigger engines and everybody driving an F-150 Ford pickup truck and an SUV. Well, all that's just ratcheted things up after 1950. Thank you very much. I'm going to move it back here so it doesn't block anybody. So, this was January of this year. This is the Earth, and this is this comes from NOAA, the National Oceanic and Atmospheric Administration, under which the Bureau of Meteorology is, that does all your measurements for weather. And we have satellites all over the planet now that measure these things every single day with great accuracy. So this isn't just made up. This is science at its very best. And this is what the Earth looked like this January. Now, if you remember, January was cold here. Well, there's us, right? Right there. We're in the cold spot. But look at the rest of the world. The rest of the world was hot. And just to tell you, this half of it was having winter. This was, our July would have been down here. And, you know, they're cooler down there than we are up there in the winter. This is very abnormal. This is unusual. These are called, by scientists, call this anomalies. That the things are not what they should be. I got to get this in the range of this thing for it to work. Come on, there you go. All right, this was March of this year. A similar but slightly different, and you can see the NOAA emblem down here on this one. But once again, March is the end of winter, the beginning of spring. And here it's the end of summer and the beginning of autumn. And the whole earth is warmer than normal, you see? The whole earth. And you see a place like this. Why is that place there so cold, do you reckon? That's in the ocean, isn't it? That's in the ocean. Why is that so cold? Yes, the ice from Greenland is pouring into the ocean right there. It's coming right there. And it's turning the ocean cold. And that is what's affecting the Gulf Stream current. And that is being dumped in as fresh water. Ice, fresh water, when it melts, is fresh water, which has a different salinity. It is lighter. And that is the cause of the decline of the Gulf Stream that I'm going to talk about later. But look how hot it is some other places on the earth. The oceans are hot, hotter than normal. These are standard deviations, so these are anomalies. The very light color are normal, and the darker colors are abnormal. So that was just a few months ago. Now, I want you to compare these two graphs. This is the global energy consumption, starting with 1900 and going up to projections into, well, this goes up to 2020, so just recent for both graphs. This is global CO2 emissions. What you should see here is that as we consume more energy, the gases go up. And the gases are what's causing the climate change, the increase of gases. So the more energy that we use, the more gases. Now, not all the energy, because some of this energy does not produce carbon dioxide. Wind, solar, and geothermal, the green, that part does not produce carbon dioxide. That's what we need, but look how much a percentage that makes of the energy, just a tiny amount. But look at ones that are bad: coal, oil, gas, natural gas. All of those have increased greatly over this period of 120 years. And so have the emissions from them. They've gone up. This is causing the problem. It's almost, they almost look identical. Yeah. Now, carbon dioxide's not the only culprit. We've got other culprits, and those are the ones that I mentioned in an earlier slide. And this is CH4, or methane, or the British call it methane, but we call it methane. But this is CH4 by chemistry, 4 parts of hydrogen, 1 part carbon. And this is a map that goes back to 1985. So you can see that we have increased our methane. Now, methane is a very potent greenhouse gas. It is equivalent to about 36 times more potent than CO2. And nitrous oxide, N2O, is about 265 and above more powerful than CO2. And this chlorofluorocarbons, they are thousands to 10,000 times more potent as a greenhouse gas. So it's not just carbon dioxide. The problem we're ultimately going to face is actually methane releases. And I'll tell you more about that in a minute. Yes?
What causes the bottom there, chlorofluorocarbons?
They are gases that are leaked, that are manufactured for air conditioners, car air conditioners, home air conditioners, and they're also used in manufacturing. And they leak. Almost everything leaks, you know. Valves leak, and things separate, and stuff just goes out. Yeah. Now, we'll start with this picture here. That looks like ice with holes in it, right? Holy ice. Well, that is what's called a methane hydrate. And the holes, the bubbles there are not air bubbles, but methane bubbles. And methane comes from the bacterial decomposition of organic matter. And, you know, cows burp methane, so it comes there. Landfills emit methane. But there is a lot of methane stored in the ice of the Arctic tundra, which is hugely expansive because it goes all the way to the top of Canada, all the way around Russia. And the area of Russia is the same area as the moon's surface. It's a huge country, very rural, but huge, and a lot of it is tundra, which you're looking at here. And that was frozen up until recently with the heating of the poles is more intense than the heating of the middle part of the Earth. That's just the way the Earth is constructed because of the fields around the Earth that carry energy to the poles from the sun. A lot of particles from the sun are captured by the magnetic field of the Earth and then dumped into the poles. And that causes friction and energy release. So this is melting, and as it melts, it releases this methane hydrate. That's why the methane emissions are going sky high right now. Nothing we can do to stop that. Now, I'm not going to go into this. This is a very complicated graphic, but it's about farms, and I just wanted to mention that farms release all these things. Farms release nitrous oxide, carbon dioxide, and methane. These different colors show where the emissions come from farms. Now, of course, we don't have food if we don't have farms. We have to have farms. Farmers could do better to mitigate their emissions, but there's no incentive for them to do so. It costs them money. But the government doesn't support them mitigating their emissions at the present time. Of course, the government doesn't support any reduction of emissions at the present time. The government essentially has done nothing, okay? Global warming. Now, we're looking now at temperatures, and I'm just going to go quickly through a couple of these graphs, but just to show you. And by the way, the ziggly lines here are summer-winter. Summer-winter, okay? So emissions go up in the summer, they go down in the winter, and so forth. So this is talking here about El Nino, and the opposite of that is La Nina. We have been very lucky because this is going to be another La Nina year. This is going to be the third straight La Nina year we've had. And that's good for us because it means that we won't get 140-degree temperatures in the summer. La Nina is a mitigating effect from the Pacific Ocean. It's a long thing. I won't go into it. It's a lot of physics in there. But we're lucky to have it. We won't have another one, though. They never go 4 years in a row. There's never been a fourth year in a row. So next year, El Nino, and El Nino is going to be hot next year. So brace yourselves. So this is a similar graph. It just shows that the temperatures, the more you go to the present, the higher the temperatures get. These are land temperatures, and this is the ocean, the sea surface temperatures. Just wanted to point out that there's that difference, and there's a lag effect. It takes a longer for water to heat than it takes for air and surface, the land surface to heat. The ocean, and you know that because you know you go into the water in May at the beach and it's cold, but you go into the water in October and it's warm because the ocean heats more slowly and then cools more slowly. It's a mitigating factor to be around water. This is another one of those long-term pictures of the Earth's climate, and this is to show you that this is a 12,000-year graph, and it goes back to the ice ages. 12,000 years ago, we had the ice ages. We had glaciers all the way down to Maryland. That's where they stopped. And so it was very cold the farther back you go into the ice age. And then this is the gradual natural climate change all around here from this up. You know, people will tell you, oh, the Earth has always had climate change. That's true, but most of that has been natural climate change, gradual, slow, and then this is the last 150 years zoomed in, which is this right here, where we are today. This is man-made climate change. This is when our overgrowth and our great industrial civilization has pumped so much greenhouse gas into the atmosphere. Every one of these is a year. This is 100 years. So you can see that about 50 years ago it was cooler, and now it's hotter. Come on, clicker, get in there. This is a decade-by-decade comparison. Every one of these little globes is a 10-year map of the Earth, like those first two big ones I showed you. And you can see that 1880 right here, that's 1880, and this is 2020. You can see the radical change of composition of the heat regimen of the planet Earth in these pictures here. So we've gone from this in 1880, and then it just got warmer and warmer and warmer and warmer, and we're up here at its hottest as ever. So there's lots of ways to depict these changes. And this is one here. Let's see if I can get this to go. There. So these are the global temperature changes by year. And see it's getting up to 1.5 degrees. And it almost got there, you see? Come on, next slide. And this is, these are all the countries of the world listed, each country. So you can see from the country how each country's climate has changed over each year. And they're all moving towards warmer, 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 warmer. The red is warmer. And this is for all the country, each country of the world. Every single country of the world has gotten hotter. Now, this only goes up to 2016. I can't get anybody to do another one that brings it up, but it continues to get redder, I'm sure. Now, this is another complex graph, and I will just say that this is a comparison of major extinction events, how the temperature, and all these extinction events, the temperature increased, okay? That was a factor in the extinctions. And it tells you here how many extinctions occurred and so forth in these different events and when they occurred. This was 56 million years ago, 201 million years ago, 252 million years ago. But look how gradual the heating was. You see, the heating was very slow. Here is the current situation. And the heating is much faster, and that's what's causing these extinctions we're having now. Animals don't have time to adjust to it, so they're going extinct. The first to crash were the insects, and that was 2012. When you guys were younger and driving around the country, you had to clean off your windshield wiper. Oh, you go to the gas station, you had to clean that windshield wiper every time. Now you can drive to Chicago in the summer and not clean it off once, right? You know I'm telling you the truth. The insects are gone. They used to smear the windshields all the time when we were young. I remember. No more. They're gone. So they crashed in 2012. Then the amphibians crashed, and the birds are crashing now because these things eat the insects. So the insects go, then whatever eats the insects, they die out next, and so forth. So here's what the future looks like. So here's the current climate. We have this much cold and this much heat. And this is, the probability of occurrence. So the probability of occurrence is shifting to the future climate. It's going to look like this with lots more heat and just a little bit of cold. And this is the scariest graph. By the way, that's one of the reservoirs out west. They're all looking like that now. There's going to be a mass migration to the east. So if you have property in the east, keep on holding on to it a little longer because the people from the west are coming here because we've got water. And they don't have water. They don't have water, and they're not going to get it. It's done for. They've got wildfires and drought. That's what they've got. Anyway, this is the future. This is the historical data ends about right here. This is where we are now. And this is the projections of the models that the climate scientists have predicted. Now, there's different models. That's why there's a spread here. There's different models that have different predictions. But they all have one thing in common. They're all getting warmer. They're all going up. Because this is the global average surface temperature above the present. And it is going up. And if it gets to 5 degrees, this is where we are now, almost up to 2.2 degrees of change. We're in about right there now. 220 is here, so we're about right there, right? Right there. So this is the future if we don't do something. But time's a wasting. We got to do something soon. So, you can prove this by the bathing suits of women. Anyway, men, women. So, the oceans are warmer now than they've ever been since we've been measuring the ocean temperature, and that goes back to 1880. The oceans absorb 90% of the heat. They will eventually absorb almost all the heat, and that will increase the ocean temperature. We have a tipping point in that the Arctic sea ice has shrunk so badly that right now you can take a boat and go right through in the summer over the poles. There's no land at the North Pole. It's just ice, floating ice. icebergs. But you can take a boat right on over the pole right this summer, and that will be done. They'll be shipping right across the top of the ocean. So it's not good. Bad for polar bears. So here's the AMOC, and there's what it looks like if you spell it out. It's a real mouthful. And this is the top of it is called the Gulf Stream, and what it does is it's a massive current that transports energy from the tropics. You know, the sun comes in directly to the tropics every day. You know, my son tells me that the temperature where he lives in Ecuador does not vary but 1 to 2 degrees off of 72 degrees every single day of the year. The sun comes up at the same time and goes down at the same time, and the temperature never varies more than 2 degrees. And he's lived there for 3 years. He's taken the measurements every year. Never more than 2 degrees difference. And it rains every day. It's a rainforest. So this is the Gulf Stream, and the trouble is the Gulf Stream is very much weaker than it ever was before. So these are all different research studies. Each one of those graphs represents a different piece of research. But you can see they all have one thing in common, that the AMOC is weaker now, right now, 2020, than it's ever been ever before measured. If it stops, whew, wow, bad news for Europe. It'll be an ice age in Europe. You know, Europe is much further north than we are. If you look at a map, people seem to think that, you know, you can go from Virginia right over, flat over to England. Oh no, you're going way up north to get to England or to France or any of those countries. To Scandinavia, even further, you're almost to the Arctic Circle. Some of them do go right through the Arctic Circle. Well, they have a nice climate up there because of the Gulf Stream, right? If that Gulf Stream stops, done. I mean, they won't have any vegetable gardens. They won't be able to grow a thing. They'll starve. They might starve also because of the Ukraine war, but that's another story. This is the picture that Nancy wanted me to show you because she's seen one of my presentations before, and I love this graphic. These are the impacts, and it starts here. If the Earth warms by 0.8 degrees, you get these changes. If the Earth warms by 1 degree, which it already has, you get these changes. If it warms 2 degrees, you get these changes. 3 degrees, these changes. 4 degrees, these changes. 6 degrees, we're toast. Most of the world is uninhabitable. That's at 5 degrees. Uninhabitable. Now, we're talking about this is possible by 2100. Your grandchildren will still be here, hopefully. That's what they're facing. This is not something that's happening 200, 300, 400 years from now. This is happening in the lifetime of a child born today. And it's preventable if Congress would do something. In 2020, we had all of these were disasters in 2020 that cost over $1 billion to fix. In 2021, I don't have a graphic, In 2021, there were $22 billion disasters. If you add them all up, in the last 10 years, we've had $721 billion spent on weather-related disasters, floods, hurricanes, wildfires, all related to the climate. You know, it would be a lot cheaper to prevent this from happening than to rebuild. Now, to rebuild these disasters, what does that do? Well, it creates more climate change because you're cutting down forests to make the wood. You are making cement, which releases a ton of CO2. Every time we have a disaster, it creates another disaster in terms of the climate. And, of course, the more people we have, the more we have to divide the food supply. So here's the UN projections for population. 7.9 billion right now. And this is what the pattern looks like. This was the time of Jesus. When Jesus was on the earth, 250 million people. Only 250, not even a billion people. Jesus. When JFK took office, and I remember that, I was in high school, there were 3 billion people on this earth. And you all remember that. You remember when he was killed, there were 3 billion people on the earth. Now we got 7.9 billion. That's in our lifetimes. Can you imagine that kind of an increase of people? And, you know, just since 1960, from 3 billion to almost 8 billion. And people are still multiplying like crazy, and it's going like this. And that's only 28 years from now. You know, that's not a long way off. 2100's only 78 years from now. You know, I bet some of you are at least 78 years old, right? That's in a lifetime, right? That's in a lifetime. 11 billion. Who's going to feed them? Where's it going to come from? Especially with climate change causing less crops being able to be produced. You see how all of this is connected? All these things are connected. Here's patterns of global consumption. You probably can't read this, and neither can I until I get right up here. The top blue is metal ores. That would be like iron ore, magnesium, manganese, tungsten, all the ores, right? The light blue is fossil fuels. The brown is non-metallic minerals. That would be like sulfur and things like that. And the green is biomass. So the consumption of these things, we're consuming all of those things at a higher rate. The more people, the more consumption. So it's related. And the ecological principle is carrying capacity and overshoot. So here's the true way to state our situation. We have a predicament and we have a problem. The predicament is overshoot. The problem is caused by overshoot, climate change, loss of food, loss of soil, melting ice. All these problems are caused by the predicament of overshoot. We've overshot our carrying capacity that the earth, the number of people that the earth can support. And what happens in an overshoot, you can see with any kind of species that overproduces the numbers. They crash. They come to a point where the population crashes. And this was observed by the Roman senator Seneca in BC times, before Jesus. And he wrote that, he noted that it takes a long time to build things up, but when they crash, they don't go down quickly. and that is called the Seneca Cliff. Things take a long time to build up, but when they go down quickly. So when a hurricane hits, all that stuff that was built up goes down real fast, right? It's a principle. And this is what we're looking to see. It hasn't happened yet, but when it happens, it's called collapse. It's collapse of civilization. So it looks like it's coming if we don't do something to stop it. And it looks like people are more interested in short-term quarterly profits of their stocks than they are about doing anything. We're still increasing by roughly 80 million people per year. That's the population of Great Britain every single year added. And it's being added mostly in Africa right now. And, you know, we have religions like Islam that permits men to have 4 wives. And some of these men in Africa have 30, 40, 50 kids because they have so many wives. And they just keep reproducing. They don't have birth control because nobody's providing it. Nobody's doing any family planning for them. By the way, even Christians in some of those countries can have more than 1 wife. So here's another problem that comes with overconsumption and overpopulation: pollution. This is the waste that's going straight up. Would you believe that the average human being in the United States of America produces 4.9 pounds of trash a day? Yeah, add that up. Where does it go? Landfills, then produces methane. Yeah. And of course, some of this stuff like plastic lasts and lasts and lasts. Some types of plastic last 500 years. Those plastic water bottles that you see people taking out of the Kroger in cases, those plastic water bottles last 450 years before they're finally decayed. And what do they decay to? Microplastics, which get into the fish and get into the food chain. And our babies, my little child that's in my daughter's womb right now, will come pre-polluted. She will have microplastic in her body when she's born. It's guaranteed. It's in everything. It's in the water now. You get it out of the tap. It's poison. Come on, click. Then you have sea level rise. This is with 2 degrees of, when we get to 2 degrees, above 2 degrees, that's going to be a 7 meter, and a meter's about a yard, a little bit over a yard. 7-yard rise in sea level. That doesn't sound like much. I mean, these ceilings are more than that, right? About 10 feet. Probably not as much as that, but 10 yards up is very far inland, you know, because the ground rises. So look at that map. This is Virginia. Aren't you glad you don't live over on the coast? The Outer Banks are gone. They are, you know, a couple of houses collapsed into the Outer Banks into the sea last week. It was on the news. Those houses are all going to be gone in another 10, 15 years. They're all going, you know, unless they move them. But look at Delaware. It'll be even smaller. And New Jersey, New York City, gosh, all those people in New York, God. Cape Cod, gone. Yeah, it's not looking good. And how are we going to pay for all that? And plus, all that stuff goes into the ocean that's flooded. And then we have the extinctions. The biodiversity is is so important because everything's connected. Everything is connected. We're losing between 25,000 and 50,000 species every year now. And we're being warned. The scientists are speaking out every way they can. This statement came from a joint edition of 200 different medical journals, all published the same warning. 200 different medical journals that know the importance of biodiversity. And we can see what happens when we start chopping down the rainforest. We get coronavirus. That's what we got, right? Came from monkeys. And now, you know, we've just lost 1 million people in the United States to it. 1 million people. This is 60% of vertebrate animals have been wiped out since 1970. Freshwater habitats have lost 83%. And South and Central America are the worst affected. I mean, this is data gathered by scientists. Deforestation, terrible in Brazil. That rainforest is going so fast, and it's being turned into farms and cattle, you know, for feeding the meat industry. This is what I love. This, the Earth is 4.5 billion years old. Let's scale that to 45 years, or 46. We have been here for 4 hours. We've been on that scale of 46 years, we've been here for 4 hours. Our industrial revolution began 1 minute ago on that scale. In that time, we have destroyed more than half of the world's forests. Half of the world's forest in 1 minute of human existence on that scale. And this is the, you know, life is connected. You know, this was first observed by a scientist that my son is named after, Alexander von Humboldt, who explored the Amazon in the 1700s and made the observation that all life, all living things were connected. And that was from his research. He lived and visited Thomas Jefferson, and they talked after he did his exploration. So he was a contemporary of Jefferson. He was a friend of Goethe. And at the time he lived, he was the most famous person on the planet. Everywhere he went, the crowds came out by the thousands to see him. He wrote about his travels and his scientific discoveries. But today, most people have never heard of him. Other aspects, I won't go into this, are heat. People simply can't stand temperatures above 98 degrees Fahrenheit for more than a few hours. You go into heat stroke. I don't know if you've ever had heat exhaustion in your life, but your organs start to shut down. You get a cascade and you die if you don't get out of the heat. And a lot of people in some very vulnerable places don't have air conditioning. Of course, the more air conditioning you run, the more CO2 you see. It's a vicious cycle. So this is a map of the Earth that shows the most places that are going to be stressed by the changing climate. These are areas that are most and least stressed. So the redder is the most stressed. And you can see that this area over here are very highly stressed areas. That's where you have 3 or 4 billion people living, right? Those are where the migrations are going to come from. And we are fairly lucky in the United States. You see that? We are fairly lucky. Now, the East Coast here and the Deep South is, and this comes up right above Virginia, but to the east of us. We, in the Shenandoah, Roanoke Valley, are actually in one of the safer places to be living. You might want to tell your kids that if they've moved away too far. I tell mine, but it is true. It is predicted that in the next to 2100, we will only average in 2100 about a 4-degree increase, where the rest of the world will be much higher. So I mean, it'll be still hot here. It's going to get hotter here, but not as bad as some places that you see in the red here. This is going to be a bad place here too. But Central America is going to be rough. And you know, Central America is already enduring a lot of trouble. And that's where the migrants that are at the border are coming from: Guatemala, Honduras, El Salvador, Nicaragua. Those places are really stressed out by the climate already. And these are regions where climate environmental shocks and extremes are predominant in the world. And extremely high severity regions where climate environmental shocks and stresses are predominant. And once again over here, lots of population in here. Here and here, yep. So I hate to tell you, but right now it's never been worse. It's going to get worse, but right now it's never been worse than, and all of those things. Look at all those things. And this is a graph of time and biosphere well-being. The biosphere's well-being has never been worse for everything we need. We have overdevelopment, overpopulation, overshoot. So all of these things, it's never been worse. Now, how long have we known about this? Here's a newspaper article. I don't know if you can read that, but it says, August 14th, 1912. And scientists is reporting that scientists are telling us that burning coal is going to affect the climate in 1912. So, yeah. And this is Johnson, 1965. That's a quote. He spoke to Congress and told Congress, we've got to do something about this climate change in 1965. And there actually was a senator that tried to do something about it. Joe Biden, believe it or not, old Joe. 1986 introduced the first climate bill in Congress. Needless to say, it didn't pass, right? So we've known about it for a long time and have done nothing about it because there were profits to be made, right? This is history, but I bought this book in 1972. The Club of Rome was not really in Rome, but it was a bunch of scientists at MIT in Massachusetts, 4 of them particularly. Dennis Meadows was the one that led the effort. And they, you know, the computers in 1972 were pretty non-existent. Most of this was done by hand. And they made these graphs. And they made these graphs and published them in 1972. And if you took all of these things and put them on a graph, they would match up. And it's been done. They were almost completely right. In 1972, they predicted almost everything that's been happening to this day. Their predictions were right. Of course, everybody ignored them. You know, they were not successful in causing anything to change, except that they were on the record as saying, this is what we need to do. So who's responsible? Well, the richest 10% are responsible for that much of the total of the problem, and the poorest 50% are responsible for about 10% of the total consumption of emissions. So, who's to blame? We are. The rich countries. The nations with the highest and lowest carbon dioxide emissions. The highest are in red. The least are in blue. Yeah, Australia's like us, pretty much. That's, of course, Saudi Arabia, the Middle East. What can be done? Well, right now, the goal should be to keep things from getting any worse. We're not going to turn it around, but we can now work to keep it from getting worse. In other words, flatten the curve. Have you heard that expression before? They've been talking about that with the pandemic, you know, flatten the curve. Don't have it be such a crisis that the hospitals close, you know. So this is what we have to do. We've got to stop using fossil fuels ASAP. We got to stop population growth ASAP. We've got to disincentivize families of more than 2 offspring. Restore forests and rewild where possible. Rewild, like make wilderness areas and let nature take over again and stop tearing it out. Promote regenerative agriculture. That's agriculture that is not chemical based. It doesn't use fertilizer but uses compost and no-till agriculture and so forth. We need to build circular economies, meaning that we don't produce a lot of plastic that goes into waste. We reuse things. We make the manufacturer pay for the collection and disposal of things so that we don't have so much trash and garbage. We need to promote preparedness, resilience, strengthening local and regional communities. So we don't want global, we don't want the United States power grids that can all come apart at once. We need regional things and local things. Solar cells on rooftops. Look at all these rooftops we've got. We could put solar cells on all of them, you know? We could build windmills. We're trying to build one at Rocky Forge in Botetourt County, but that's been stymied by lawsuits. Stop defining and measuring progress in measures like gross domestic product. We've got to have a different measure, something that measures human happiness or something else like some countries do. Not about profits at the end of the quarter. We got to stop talking about manufacturing more and more consumptions and buying things that we don't need. Be nice if we could end all those commercials on TV for things that we don't need. And anyway, political will is something that we don't have right now. We could use some of that. So this is what it looks like if you flatten the curve. Things will probably still crash, but we'll have more time to get ready for it and save more lives. If we don't, we're going to have a real big crash here. Global temperatures going up. It's going to cause the crash. This is 2 degrees right here, and we're approaching it. So, work for change. I try to do this. I work with Plowshare Peace Center, the Sierra Club. I'm the secretary of the local Sierra Club. The organization that is sponsoring me, or not paying me, but volunteering through, is called RAISE, Roanoke Area Stewards of the Earth. I've been giving these talks on their behalf. They have a speakers bureau, and you can get more speakers on other topics from there. And we need to prepare, we need to change our habits, reduce consumption, conserve energy, use less, especially plastic. Plastic results in a lot of carbon dioxide emissions. And we need to go solar. And we need to garden, local gardens. And we need to take care of ourselves by Sabbath times. We need to spend more time in nature and in rest. Now, that's probably not a problem with you all, but it might be with your children, right? Because, you know, people are frenetic in some of these occupations they have. So that's a nice graphic. Right? Ask your elected officials when they are up for office what they're going to do and hold them to it. And here's a local issue. Mountain Valley Pipeline. It ought to be stopped. Ought to be stopped. That thing will leak. All pipelines leak, and they leak methane. And they will leak at the compressor stations. They'll have these compressor stations to pump up the pressure. This one is the biggest, largest diameter one ever built in the country. And if it gets built and if it has a spark and blows, it could kill hundreds of people. It'd be a real disaster. So it needs to be stopped. And I'll let you read that. That's a quote from Chuck Bowers, one of my friends, actually. I know him through academia. He's an academic. So everything right now is serving profit company. Everything now is about profit and serving corporations. We need to change that and have things serve the people of the planet, us, you and I, and not corporate profits. And in terms of final thoughts here, just, you know, there are still people that are climate change deniers. And I have lobbied both Congressman Morgan Griffith and Congressman Ben Cline in person in the past. I have asked them, both are deniers. And yeah, although now Morgan Griffith does admit that the climate is changing, but he claims it's natural, just a natural thing that has always happened. Same with Cline. And he says, oh, it's changed for centuries, you know, it's no big deal. And he minimizes it. I've been moved now. I live in Salem. I've been moved into Kline's district now, so I'll be seeing him as soon as the pandemic allows. He won't see anybody right now in person. All right. Yes?
Are the economists and the scientists talking?
Yes. Yes, they are. That's what the circular economy is about. There are economists that have proposed economic systems that are not driven by profit, but are driven by community needs and situations. Yeah, they are. Well, the politicians are not listening. They're only listening to their campaign funders. And you and I may be their campaign funders, but I can't give what Exxon can give, you know, and they're listening to the biggest donors, whoever can give the most. Well, that's the problem. We need to get Citizens United reversed. That's the Supreme Court decision that said that money is speech. That was a bad decision. The worst decision they ever made, except Dred Scott maybe. But that money is speech is wrong. We need to get publicly financed shorter campaign seasons like they do in Europe. I mean, 5 or 6 months should be enough, not 2 or 3 years, you know, and limit the amount of money spent, limit the amount, so that we won't be inundated with those TV commercials over and over and over again that cost thousands and thousands of dollars. It's money wasted. Yes?
I'm a life member of the Nature Conservancy. Am I making a difference?
Yes. Nature Conservancy is one of my donors. In fact, I have them in my will as well. Yeah. Did you? Yes, ma'am.
Don't you think that the way we vote in November and in 2024 will make a difference?
Huge. Yes. Will it make a difference how we vote in November, this November, and in 2024? Yes, it'll make a huge difference. Yeah. Yeah. Yes, ma'am.
To know what kind of reception you get when you elaborate your presentation like this, so it has to be
Well, I have never made one in high schools, but last 2 weeks ago I made it to the Teamsters Local 171, believe it or not. And of course I knew I was going to have problems there because they are truck drivers and they emit a lot of CO2. So I didn't have a very positive reception there. But I knew that was going to be the case, so I just tried my best.
entrenched into the topic. This is like, you know, maybe even junior high school, junior colleges, younger people.
Well, if they invite me, I'll be glad to do it. Yeah, you know, I'll be glad to give this talk to schools, any school. Yeah, yes, ma'am.
How can we control Mother Nature after we do all the fixing she comes along and destroys so much?
Well, you can't control Mother Nature. And there's an old saying that nature bats last. You know, she's going to have the final word in this, not us. You need to work with Mother Nature. That's what you need to do. Is learn how she works and work with her, not against her. There are a lot of people that think we can fix this situation with technology, like putting mirrors in space or dropping seeding clouds and things like that. That's very dangerous because you don't know what other things might happen. You know, they call things, when you take a medicine, you know, you hear these ads for medicines and say, well, the side effects are, well, there aren't no side effects. There are just effects. There are effects, not side effects. There are effects. And a lot of different things can happen. So, you know, these medicines will say, well, you take this medicine, there's a chance you're going to die. The medicine will kill you. And it does kill some people. But that's the trouble with these technological fixes. You don't know what the side effects are, the other effects. So it's a problem. I've seen you before. Yeah. Yes, Sunday. Yeah, yes.
One more question. The people who get their water supply from Lake Mead and Lake Powell, what are those people gonna do?
Put out rain barrels and hope for the best, but you know, it's not raining out there, and it's really desperate for some people. Well, they're buying water in grocery stores is what they're doing. Yeah, they're buying their water, and that's more plastic, and of course the water is shipped, so the shipping of it is more CO2. We got to cut down on this trucking of things, and of course, you know, we got to learn to eat things that are locally seasonal and not buy things that are coming from South America or China or someplace. Well, I know it's lunchtime for you all, and I thank you very much for your attention. And I have a handout for you. Do you have the handout? Oh, you got the handout. Okay, you got the handout. And I just wanted to point out to you that if you get the May issue of Senior News, if you ever go to Food Lion, you can pick these up. I have an article about climate change in here. They published an article.